So let's talk about inclined planes. Inclined plane without any friction. A 3 kilogram object is going to slide down this inclined plane and we're going to solve for the acceleration. What is the first thing we do with all force problems? Everybody died. So what are the forces acting on the 3 kilogram object? Gravity acts straight down. Normal force and anything else? That's it. Now what's causing this thing to slide down then? Gravity, or a piece of gravity that is pulling it down the plane. Next thing we do is we deal with the angle. Now we want to rotate our axis so that the y direction is that way and the x direction goes down the plane so that the acceleration is in one of the cardinal directions. One of the primary directions, y or x. In this case, the acceleration is going to be in the x. So we need to find the piece of gravity. One piece goes downwards against normal force. One piece goes on the plane. And that's the piece of gravity that's causing our acceleration. So what are these two values? Angle of the plane goes here. So let's do the green value first. What is the value of gravity in the y direction? It's cosine because we're on the adjacent side.
Cosine 30 times.
Yeah, right. Cosine 30 times the hypotenuse, so mg cosine theta. And the blue side, or the x direction? Mg times the sine of the angle. Once we've got those two values, we throw out the hypotenuse of the triangle. We don't want to confuse that with anything that goes in our problem now. This piece goes in the y, this piece goes in the x, and as far as we're concerned, that's all that matters.
Okay, so just to make sure I understand, you're going to draw the gravity's always going to be hypotenuse, and then one last will be adjacent to the normal force that you just connected with the correct?
Yes, one of the components of gravity is going to be pulling it down the plane, or in your x direction. One of the components of gravity is going to be pushing it out of the plane. It represents the normal force, basically. Now, it's not always true. We only break down force of gravity here because our axes have been rotated. If we didn't rotate our axes, if we kept our axes like this, then gravity would be acting straight down. We wouldn't have to deal with it. We would have to break down the normal force into its components. We would do that if we were talking about a circular track where the acceleration was that direction. So you have to rotate your axes so that the acceleration of the problem is along one of your axes. In a circular motion problem, it would have been along the x-axis here. In this problem, we're accelerating down the plane, so we want to rotate our axes so that mg sine theta pulls us down. All right, now that we've broken down the angle, what do we do? Some of the forces on the x or the y direction. In the x. Our acceleration is going down the plane in the x, so since we're solving for acceleration, let's do that. What forces do we have in the x direction? All we have is just the one component of gravity. Mg sine theta equals ma.
Can you give us all three colors of advantage for all these tests?
At this point, you can divide by the masses and show that the mass doesn't make any difference. I'd prefer it if you went ahead and did that. The mass isn't going to make any difference as long as you're not friction. If you have friction, then you need to leave it in there because it won't cancel out of every term. It won't divide out of every term. If you had friction, you would have that mg sine theta pulling you down the plane, but you would also have friction pulling you up the plane. So that's minus friction equals ma. In this case, you cancel out. You can't divide by the masses because this guy doesn't have any mass. You can divide by them there, but you'd have to put one in the middle term as well. And that just makes it complicated. So when you have friction, leave it in there. When we go through that problem, you'll see that most of the time, mass still doesn't matter. But that's for another problem. Gravity, 10 meters per second squared, sine of my angle 30 degrees equals our acceleration. 10 sine of 30, 5 meters per second squared, that is our acceleration.